So thank you so much for joining us. You are here for the second Level Up with Fusion 360 for Secondary Education webinar. My name is Jason Erdreich. I'm a technology and engineering educator, and I am teamed up with Autodesk to provide these types of training resources for teachers to make sure that you are supported as you engage your students with all of the awesome Autodesk features and products. And I'm joined, as always, by my co-host, Randy.
Hi, I'm Randy. I am on the Autodesk K-12 team, and I work on Tinkercad and Instructables and some Extent Fusion. And I'm here to help out with the webinar and the chat, run the polls. And I'm happy if you have questions, put them in the Q&A, and we'll be happy to answer them.
Yeah, and thanks, Randy. And whenever we do these webinars, I'm always joined by a number of Autodesk team members. So we also have Nicole working behind the scenes. So you'll see her popping up in the chat, answering their questions throughout. We might have some more Autodesk team members join us throughout the evening. And there also will be a dedicated time at the end of the webinar to get face-to-face with everyone who's here with me. So thanks, everyone, for helping out, as always, from the Autodesk team. So the Level Up with Fusion in Secondary Education webinar series is going to run throughout the year. This is formally our second webinar from the series, and we have a number planned throughout. This is the last one for 2023, I should say, but we have a number planned for 2024 as well. So looking ahead after this webinar, we're going to take our holiday New Year break, but we'll be back in January on the 18th for another webinar called Rendering and Animating. And we'll get into a little bit of what that's going to look like in tonight's content, but we have a number planned even after that. And if you're familiar with the Teaching with Tinkercad webinar series that we've been running also, that will also be back in 2024. So definitely stay in tune with the Tinkercad blog to keep up to date with the upcoming events, the schedule, all those things, because we have a number of things planned that we're super excited for once we enter the new year. Now, before we dive into multi-part assemblies, which is the topic of tonight's webinar, we're going to launch a poll right now, and we would just love to get specific experience with Fusion 360. So are you just getting started? Have you ever used it before? Are you very new with it? Do you consider yourself an expert? So please just take a moment to answer that poll that should be on your screen. We love to tie in topics that might suit your needs as much as possible. So if I can kind of see what my user base here is, I'll try to gauge the conversation specifically to what you're looking for as much as I can. I also see some great questions popping up in the chat, and I see that Nicole's already on it, dropping a link. So yes, all of these webinars are recorded, so you can always go back and not only see tonight's webinar once we post it tomorrow, but you can also go back and see the first Level Up webinar, as well as all the ones that we've run in the past. So it looks like the vast majority of us are just getting started with Fusion. Some of you have a little bit of experience, and maybe you've used it a couple times, but it seems like most of us here are new. And that's great because you are definitely in the right spot, which is super exciting. So I'm going to be kind of taking you through the basics as we learn specifically about multi-part assemblies. And Fusion's such a diverse program that I'm going to try to bring in a wide range of conversations with as much time as we have here as well. So let's talk about how to participate. You're already doing a great job. We love to use the chat. So the chat is the best way just to drop in some questions and things like that. As I mentioned, Randy and Nicole are with me, and they're going to be working throughout the night to answer your questions very promptly. If you have a specific question, we also recommend that you use the Q&A feature. Q&A will allow your question to stay there until we answer it, and then everyone can also go back and see the questions as well. Sometimes the chat scrolls really, really fast. So we use the chat to drop links to things and definitely keep an eye on it throughout the webinar. But if you have a question, we also recommend you drop it in the Q&A. And at the end of the webinar, after we go through some content and things, there's going to be a dedicated Q&A session where you can see all the team members' faces, and we'll just answer your questions directly as we work through and kind of review what we've covered. And again, not only is the webinar recorded, and that will be shared with you, but these slides as well. So throughout the evening, I might be demoing something live, but there's going to be a slideshow with links and useful resources also emailed to all of you tomorrow as we kind of wrap things up and share all the resources. So before we dive in, I know a lot of us are new to Fusion 360, so let's just talk about what Fusion 360 is. It has a number of applications and abilities kind of built into one application. Kind of like in Tinkercad, you might have circuits, code blocks, and the 3D design feature. Well, in Fusion, you can do 3D design and modeling. You can also prepare designs for manufacturing, like 3D printing, which is what we did in our first Level Up with webinar, Level Up series webinar just 2 weeks ago. And we have one for CNC planned in the new year. You can also make printed circuit boards. You can simulate parts to see how they might break. You can use generative design to help you design better. And there are tons of features to actually collaborate and share your designs, whether it's students working in a group or you viewing your student work. And we'll definitely cover a lot of that tonight. Often question I get is why would we use Fusion, or why would I transition my students from Tinkercad to Fusion? And that's a really great question. Fusion is a full-fledged professional industry standard, or at least industry themed CAD program, meaning that the same types of careers that your students might be entering one day, they can gain those skills in Fusion 360. It is extremely real world. We talked last week about creating technical drawings and making complex 3D models and getting into manufacturing as if we were considering going to some type of engineering career. So by teaching our students Fusion, we're really teaching them those real world skills at an earlier level and empowering them to really create just about anything. So it's a really powerful program for students that are looking to enter into these different fields as they get to learn all these different skills. And it's so capable that they can really bring their ideas to life as if it was a real product or system. And one great way to do that is through Assemblies, which is tonight's theme. I also want to just answer a couple questions that I see popping up. Yes, you can also access Fusion in the browser, just like Tinkercad. So there is a desktop app for Windows or Apple Mac computers, but you can also load Fusion in like the Chrome browser on a Chromebook, just like you would do with Tinkercad. So whatever device you have probably works with Fusion as well in your classroom. So that's really great. Fusion's also free for students and educators. So you do need to create an Autodesk account, but it's free to do that for education, which gives you unlimited access as an educator or for your students. There's different age limitations depending on where you are. So for example, students would have to be 13 or older in the United States, and that varies a little bit from region to region, but it's completely free for students and educators to create an account and start working with Fusion. There's also something called Fusion 360 Teams. And this is a cloud-based, which means that your students' designs are saved to a cloud. It also means that it's super easy for you to, say, make a class within Fusion Teams and have your students join that class so you can see their designs, check on their work. Students can share designs between group members and kind of be collaborating within a single document. So it's very, very powerful in the classroom setting. And that's, of course, included with Fusion 360 and with the account that you create. And another common question, and I'll actually demonstrate this too when I get live and hands-on with Fusion, is sometimes when you're getting started, it's just the controls are slightly different if you're coming from Tinkercad and going to Fusion 360. But Fusion 360 is completely customizable. So you can customize the way that the mouse works, the way that the clicking works, the way that selection and zooming works to actually mimic, say, what you're familiar with in Tinkercad. And that's something that I know myself, and I think the whole Tinkercad team definitely does. Is the first thing is makes Fusion feel more like Tinkercad. So it's a bit more comfortable for us to transition to this program. So that's a super handy feature. And I see Randy just dropped a blog post in to the chat to see how to do that. And you'll notice that in the slideshow, there are some hyperlinks. So when we share the slideshow out, there's some hyperlinks to different resources that I'll be talking about throughout the night. So you'll be able to kind of go back and review all these things as well. So that being said, designing multi-part assemblies, what does that actually mean? Well, it's one thing if you want to design a single part, like for example, last week, or last webinar, I should say, I was talking about designing a 3D printed mug or some type of 3D printed jar. But a more complex real-world design is making parts that actually assemble together and fit together and lock together and rotate and slide. And we love to use Fusion for this because not only can you make super complex designs, you can simulate how they would actually be constructed. We can see if they're going to move as they should, and we can kind of test our models in Fusion 360, which again kind of brings in those real-world complex concepts. And that's exactly what we're going over in our demo tonight through a few different projects and scenarios. And this is going to empower your students to really kind of plan and prototype their designs through like an iterative process, right? So instead of just 3D printing and realizing it doesn't fit, we can do a lot of these testings and things in Fusion, which is something that a real company would do. They would simulate everything digitally before they go and manufacture it. So again, it kind of goes back to what I was saying earlier about why Fusion, get to bring those real world concepts right into the classroom. So the first thing I want to show you is how to actually start in Tinkercad. That being, I know that so many of us from your poll is coming from Tinkercad. So it's super easy and actually a lot of fun to bring your Tinkercad designs into Fusion 360. So what you're looking at right now is a toy car that I have in my Tinkercad design here. It's got multiple parts, and I want to show you how this is grouped together because a lot of these things will import directly into Fusion, which is super great. This car body that's in red, that is a single part. This wheel and axle, wheels are individual parts. The axle is individual parts, and this spoiler fin thing on the back is also an individual part. So I have multiple parts here that aren't grouped together, and that's actually going to be brought into Fusion just like I have it designed, which is super exciting, colors and everything. And to bring something into Fusion, it's very easy to do. You can just click the Send To button, and also the Export button. I believe there's Fusion under both, as you can see. And there's this nice little button here to hit Take Your Design Further with Fusion 360. And when you click on this, you'll have a number of options. The first thing to keep in mind, and it does warn you about this, is only native parts will be imported, meaning all of these basic shapes will be imported, including the scribble tool. But any of these shape generators or custom shapes and things like that cannot be brought into Fusion 360. So you can bring in any of the basic shapes that are created with our basic panel, and these are all basic shapes here, but other shapes will not be imported. The other thing that you might want to do is you can actually connect your Tinkercad and Fusion 360 account. So I don't have a team listed for the account that I'm signed in with right now, but let's say I was a student and I was part of your class, a Fusion 360 team, it would appear right here, and I can actually send it directly to that class. Alternatively, I can actually download this and open this up directly in Fusion, and if I wanted to, I can export every single thing or only a selected shape if I wanted to. So if there were things in my design I didn't want to bring over, you have a lot of flexibility when you do that. And give me one moment, I will show you as I bring up Fusion. We have our toy car. So it comes over exactly in terms of grouping and things like that as it was in Tinkercad, as well as colors. You can see it's still red and black and gray. And in Fusion, I have all of these bodies, and these bodies are those parts. So you can notice I can click on these different bodies here, and I can highlight the individual parts. So whatever wasn't grouped or was grouped came over as solid parts in Fusion, which is really cool. And there's another couple great things, and we talked about this in our last webinar about why you might want to bring your designs into Fusion. You'll notice that this design automatically looks a little bit smoother, right? So our mesh models are merged into solid shapes, which means I can actually click on edges of my design. Everything's a bit smoother and a bit more refined just because I brought it into Fusion 360, which kind of automatically reconfigures and re-renders all of your parts. So it makes it nice and smooth. And it gives you some really great customizability features. Like, for example, if I wanted to get rid of some of these rough edges, I could just grab my fillet tool and I could click on an edge here and round it over and enhance my design as I go. And I can actually do that to a number of edges. Let me click on some edges here, and I can customize my car a little bit. Maybe we'll click on this edge and just sort of smooth things over as I want to enhance my design that I brought over. So this car was designed in Tinkercad, but I can work with Fusion 360 to customize it, enhance it, and of course work with assemblies. So lots of really great features just by importing your design over here, which is super cool. I mentioned that you can also customize and change colors and things. So all of these shapes that we have can be customized. So for example, if I find my car body shape, I can right click this and I can edit the appearance. And Fusion has a number of materials kind of built in. So for example, I might want to actually go to my metal category and maybe go to gold and set my car to be gold, which is of course super fun. Or I can actually mix, I can get very specific as I mix my colors and things. So you have a lot of customizability in how you actually want to make your models appear in Fusion as well, which is also super fun. So lots of great customizability as you bring your models in. Now, one thing that you want to do or get comfortable with as we're working in Fusion is using the browser, which is this menu over here. The browser shows all of the parts, all of the features, everything that you do in your design. And if you've used Fusion before, you'll notice that the timeline is missing from the bottom. A timeline, and if I go to another Fusion document like this one here, you can see the timeline shows me the step-by-step features of everything that I've created. Now, when you bring a Tinkercad design in, this timeline isn't shown by default, but we can actually right-click our model up here in the browser and click Design, Capture Design History. And that means that everything I do moving forward will show on my timeline. And the benefit of that is it's super easy for me to modify and going back and adjusting things. So let me add, for example, a chamfer on the outer edges of my wheels real quick. Now that I've captured my timeline, and you'll see that the changes and things that I do, like this, now appear down here. So I have this little chamfer icon. And if I wanted to go back and adjust this chamfer, let's say, for example, I don't want it to be 2 millimeters, I want to go back and change it to 1 millimeter, I can just double click on anything within my timeline, make a change, and it'll automatically update my model. So if you make a brand new design in Fusion, that's automatically going to be there. But if you bring something in from Tinkercad, we can import our timeline just to make customizing and adjusting our model a little bit more fluid. Something else we want to do is, or should do, especially when we're getting into assemblies, is naming our bodies. So later on, we're going to be kind of grouping parts of the car together and making it roll and do all of these really exciting things. But it's really hard for me to know, all right, what is my front right wheel? I kind of have to hover over these bodies to sort of figure this out. So I always recommend that when you're making a complex assembly, name your bodies. Whatever works for you. So I don't always do the most geometrically spell checked names per se, but I like to know what I'm working with. So that way, as I try to group things together, it's a little bit easier for me to do. And this is going to really benefit your students in the long run as they're designing complex models. Because if they want to hide something or group something, it's super easy to do. I'm sorry, it's kind of hard for me to type and spell check myself and talk at the same time. Here we go. Spoiler, and then this is just our car body. So let's say, for example, I wanted to, inspect my front axle. I now know what my wheels are, and I can easily hit these little eyeballs right here and hide those parts. And it just gives me a little bit more control over my models. And if you're designing a single part, that's not super important. But once we get into complex assemblies, the more organized we can be, the better and the more successful it will be in the long run. Something else that's super important with Fusion is also creating what's called components. So a component is essentially an independent part. I have independent bodies right now, but they're all within my toy car part. So let's say, for example, I wanted to adjust just this wheel. If I wanted to move this wheel or rotate just one wheel, I can't necessarily do that right now. But if these were independent components, I can sort of adjust them and manipulate them and work with them individually. And you can right-click any body and turn it into a component one at a time. Or if I right-click my whole bodies folder, I can create components from all of my bodies. And you'll notice my browser just changed a little bit. I still have the same names, so all the names that I have transferred, but each part now has its own little sub menu of features and bodies and things like that. And why is that beneficial? Well, let's say, for example, I just want to move this one wheel. Now I can. These parts kind of now roam freely, so I can move them around individually. And obviously, this is kind of more similar to Tinkercad. You can kind of envision that every shape is its own component initially, because you can kind of drag it and manipulate it, right? So in Fusion, by turning these into components, we have these individual parts, which we can assemble together, but we can also now kind of manipulate and drag around freely by turning them into components. And that's a super important thing as we start to get into more complex models and assemblies. And if you disassemble your car or your part or your model like I did, and you want to put it all back, you'll notice that I have this nice little position button here. Capture position will save this position as my new kind of home base. So it'll keep all my parts sort of exploded like this. Revert position will take me back to where it was before I started dragging things. So if I'm just designing something and I need to quickly move this wheel out of the way, I can do that and I can revert it back. But as I already showed you, you can also just hide components in the browser. So you have a lot of customizability. And you might notice that my toolbar looks slightly different than yours. Fusion, as I mentioned, is completely customizable. So let's say that there's a tool that you use a lot. Like for example, one of my favorite tools is change parameters. You can add things to your toolbar. So I can pin tools to my toolbar. I can remove things from my toolbar. And as a teacher, I always like to kind of figure out what the tools I'm going to use in my class are initially. And then the first day in Fusion, we kind of run through with my students together. We set up our toolbar. We grab the tools that are most important that we're going to use. We want to highlight. We customize our toolbar as well as our Zoom settings and things like that, which we talked about earlier. So lots of really great ways to actually customize your Fusion experience and your toolbar as you're working. Now, I mentioned parameters briefly, and I want to kind of dive into that a little bit deeper. A parameter is kind of like a variable, or it is a variable, I guess I should say. So I'm going to click on this parameters, create parameters button. And again, it's on my toolbar, but this is under the modify tab. We have change parameters. And what this allows you to do is create variables, which you can call upon. Like, for example, let's say that I was going to set the length of something the same many, many times. I might call that length 1. And every time I want to set a measurement, I don't have to know what that number is. I can just say, hey, set that to be length 1. One thing that I always like to do is create a tolerance for moving parts. So let's say, for example, I really was going to make this car and I want my axles to roll within my car body. I do have holes here. So if I drag this axle out of the way, you can see that there's a hole, but the hole size is the exact same size as my axle. So if I was actually going to 3D print this, that would bind. That would be really, really tight. And it wouldn't actually spin. It wouldn't actually roll. So I like to create a parameter for tolerances to add wiggle room for my moving parts. And then that way, whenever my students are designing, let's say they set something to be 20 millimeters, but they want it to be a moving part, they can just say 20 millimeters plus tolerance. And it's going to allow them to more easily create some flexibility in their models. So let me show you how to do that. I'm going to open up this change parameters, and I'm going to make a new parameter called tolerance. And I'm going to set this to be half a millimeter, so 0.5 millimeters. And I can even call this like loose fit for 3D printing and mind my spelling. Now, if I wanted to go set a dimension for something, like for example, let's hide my front wheel and let's hide my front axle. Let's say that I actually want to add some wiggle room. I want to widen this hole here with my tolerance. Well, I could use, let's say, the press pull command or tool, and you can see that I can change the size of this hole and I can set like a specific measurement. But now that I've created the variable called tolerance, I can just type in the word tolerance and it's automatically going to add or adjust. And we can see that it just added tolerance. In this case, I actually want to remove tolerance. I want to make this slightly bigger so I can actually even type in negative tolerance. And maybe to show you what I'm talking about, I'm going to bring my axle back. And you can now see that there's a gap all the way around my axle, which is super cool. So that would actually allow this to roll. And I mentioned one really intentional way to use this is if you're going to use this measurement over and over again. So let's now go to the back axle. And I'm going to, again, do a press pull command. And I'm going to say negative tolerance. And that's going to add the wiggle room to my rear axle as well. But here's something super cool. Let's say I change my mind. I don't want this to be half a millimeter. I can just go in and adjust my measurement here. And let's say I actually, let's say I want this to be 0.25 millimeters. It will actually update everywhere I use that variable. So I don't know if you can see, because that wasn't a huge change. Let me make this a really big change. Let's make this 2 millimeters. And you can see that my hole size just increased a lot. I didn't change that at all. So that's just now adjusting everywhere where I put this tolerance variable. It's automatically adjusting. And now let's talk about, let's imagine that you're 3D printing with your students. If you're 3D printing with one filament, that might shrink at a different rate than another filament. So you might have a tolerance that's adjusted based on how you're building this or whatever it might be. So this is a really powerful tool as you are working with your designs and your assemblies by creating parameters. So I'm going to set that back to half a millimeter, give us a little bit of wiggle room with our axles here. And then I'm going to just bring my car kind of back. If you're coming from Tinkercad, you'll notice you kind of have your view cube here. So you can rotate and orbit around, super handy. And then you also have a bunch of different tools at the bottom of your screen to pan, zoom, etc. I am right now right-clicking and dragging and zooming in, just like I would be doing in Tinkercad, because I've adjusted my screen like Tinkercad here, as we talked about earlier. So now that we've kind of considered components, tolerances, changing component positions and things, let's kind of talk more about assemblies. And at the moment, I'm working with a model where the parts were brought in kind of pre-assembled, right? In Tinkercad, I aligned this to be how I wanted it to be. But in Fusion, you have a number of ways to move things around. If it's a component, as I showed you, you can just literally drag this anywhere you want it to be. But if this is sort of a loose drag, right? I can literally put it anywhere, even if it's somewhere wrong, like in the middle of my car. So you can accidentally put something in the wrong spot. So there are more precise ways to move things around. We have the Move Copy tool, which if I click on my part, I can actually click on any specific origin point. So for example, I want to move my part specifically from this face, and I can move things more accurately. So for example, I can move this exactly 30 millimeters away in the Z direction based on how I'm currently oriented or whatever it might be. So this gives you a little bit more control as you move things. This is also a great way to make a copy of something too. Let's say I wanted a copy of my wheel. I could actually click on this wheel and hit create copy. And now when I move it, it's actually going to make a copy when I move. So that's another little handy trick from moving things around. And then there's also an align tool as well. And the align tool is sort of like an assembly that isn't permanently constrained. So what I mean by that is I'm going to hit the align tool, and I'm going to say that I want this face to snap to this face. And you can see, while it's not aligned centered per se, it is now aligned perpendicularly to my face. Let me actually kind of go back here. And let me say instead, I want to align this inside face to this face. And then I might also want to align this face to this face. And work my way around little by little to actually snap models. And you can see that this might not be the smoothest way to do this, but it is a little bit more accurately than just trying to drag something and get it perfectly in place like that. But I mentioned that this isn't a constrained assembly. And what I mean by that is it's not necessarily like a joint or something that we can apply motion to. That is a little bit different. So if we look under our assemble menu, we have joints, we have as-built joints, we have rigid groups. These are actual constraints and relationships between components, meaning that if one moves, another kind of moves with it. They're linked together. It's not just the placement of where they are on the screen. They actually interact with one another. And if we want to get into creating things that can kind of simulate motion and simulate assemblies, we're really working in this assembly menu here. Now, the first thing I like to do is group everything together that moves together. So what I mean by that is I want this front axle and these two front wheels to be grouped together. I want them to move together. And I have two ways to do this. I can create an as-built joint because they're already in the position they need to be. So I can click on this component and this component, and I can say that this is a rigid joint. And what that's going to do is anytime one moves, the other moves with it. So if I now drag my wheel, you can see that the axle is coming with it. So that's a rigid joint, as I have here, things that don't that move together in unison. And you'll notice that a new folder appeared in my browser called joints. So if I ever want to go back and adjust a joint that I created, I can actually edit it from my browser, change things around. Everything kind of appears here as we adjust it. But I actually like to create rigid groups instead of rigid joints because it gives you a little bit more control in terms of how many components you can select. So a rigid group is automatically going to be set to be rigid, meaning that these things will move together in unison. And I can select more than just two components. So what I'm doing right now is I'm making a rigid group between my front axle and my two front wheels. And I can click OK. And now this whole front subsystem of my model is a group that moves together. And I can actually rename this if I wanted to. So I could call this like front drive, because that's my front drive system. I'm going to make another rigid group with my rear drive system. So we'll go rear axle. Oops, I accidentally clicked on my car by mistake. Here we go. Rear axle, wheel, and wheel. Click OK. And we're going to call this our rear drive. And right now the spoiler is a separate part from the car body. So I'm also going to make a rigid group just called car. And you want to make groups and assign constraints with everything, because what you might find is if you don't assign something as a group, or if you don't set it to be rigid or not, all of a sudden one thing will move and the one thing won't move like you expect it. So as you're looking at your model, you want to assign these constraints to all of your parts, all of your components, to whatever they're supposed to do. If they're supposed to move, set them as motion. If they're not supposed to move, set them as a rigid or a grounded component to make sure that everything kind of interacts as it's sort of supposed to in the real world. Now, I want to go back to this as-built joint menu that I opened before. Again, as-built joints are when you already have your models in place. And I'll show you what if your models aren't in place in a moment. But at the moment, this car, everything's in place. It's where I want it to be. I just want to add my relationships and how they interact. So I'm going to hit my as-built joints. And we're going to select my axle. So I'm going to hide my wheel. And I'm going to select my car. But this isn't going to be rigid. I'm going to set a revolute motion. And I also need to select a snap point, meaning like, what is my revolve point? How is this going to revolve? And I'm going to select the outer edge of the hole that the axle slides through. And I can click this little preview motion here, and you can see that my axle is now spinning as it should be. And I can change the direction that it's spinning and set different parameters and things like that if I need to customize this, and we'll dive into that in just a moment. And if I bring my wheel back here, I can, let's see, go back into my motion and preview this, and we'll see that, oops, sorry, hang on, let me ground my car here. See if this works. And I should be able to drag this. So I can just drag my wheel. And what's happening is you'll notice that both wheels are moving and the axle's moving. This whole rigid group is moving together as I drag this. Now let's add this to our rear group as well. So I'm going to make another as-built joint. And I'm just going to hide this back wheel so I can see my parts. I want my axle, my car, and the snap point again is going to be the axle hole, like so. Okay. So now if I bring my wheel back, I should be able to drag this. Great. And something else I can do is I can link these together. We know that in the real world, if this car was rolling, when the front wheel rolls, the back wheel should roll, in theory, if this was rolling down a hill. So I can actually create what's called a motion link, which is saying that, okay, when this joint spins, this one should also spin. So now my wheels are going to roll together. And I think this is rolling backwards, but I can make this roll forwards or whatever it is that I want to do, and also set my angle and degrees. But I can now drag this front wheel around and see my back wheels spin as well. So we have these nice little as-built joints and our motion links, so we can kind of see how that works. Now, you'll notice that under this menu, there's also the joint, right? So as-built joints, again, is if your parts are already in place. If you've designed this to be in place, you can use the as-built joints. But what if I have parts that are not in place? So for example, here is a gear plate or some type of threaded plate of whatever it might be. Okay, base plate is what my part's called. And in another Fusion document, I have a gear. So what if I want to bring these two documents together? What if I want to bring this gear I'm calling it a gear, but I guess it might be a tap or something like that. If I want to bring this part into my other one. Well, I'm going to right-click my component and hit copy. And then I'm going to head on over to this document and hit paste. And now I have my gear part. And when I bring this in, I'm automatically shown the move window. So I can sort of position this sort of loosely or wherever it is that I might want it to go as I bring these parts together. But let me show you what this joint feature does. So with joints, I can make parts not only have constraints in terms of motion, but I can also make them move into position. So for example, I want the top of my, oops, and I think I clicked on that in the wrong spot. Let's try this again. I want this to be centered here. I want from the center of my post to the center of my tap to be aligned. And you'll notice that this now not only gives me the options for motion, like for example, revolving, it also moved things into position as well. So again, I want to recap that because I always, when I first got started with this, I would always click joints and I was always saying, wait, why are things moving away from where I want? So if your parts aren't where you want them to be, you can use a joint, which moves things where they should be, as well as allows you to set them to be rigid, motion, etc. If your parts are already where you want them to be, so you design your model with your parts in place, then you really want to use the as-built joints so you can apply the motion without needing to move them. But Fusion gives you the capability to kind of assemble things based on however it is that you design them, which is super cool. Something else you can do is set limits with your parts. So I have this slide box, as you can see, and I have this lid, which if I, hang on, move my lid out of the way, there we go, you can see kind of fits within my box. And I also have our tolerance variable that we talked about earlier, right? But I know that this lid, in theory, should not come all the way over here. I want to just see this slide within its track. I also know that the lid can't do this. It can't come through the back of the box. I know that because I designed this part, but Fusion doesn't know that, right? I need to teach Fusion what the limits are of this assembly. So we're going to do another as-built joint because these parts are already where I want them to be. And I'm going to say that I have my lid component and my box component. And you'll notice right now I'm on Revolute, which is going to look super weird and wrong because if I do that, it's going to try to, it's actually saying that I can't revolve around that. We're going to change this to a slider. And I'm going to say that I'm going to slide along this axis. And as you can see, this is super cool. My lid is sliding, which is great. But it's also not sliding how it would be in the real world, right? That's not what we want to do. So I'm actually going to set my limits. Okay, so I'm going to set my minimum of 0 and a maximum of 110. This model now kind of acts sort of like it should in the real world. My lid isn't going off the back of my box. It is constrained as the part would be. And while it took a little bit of effort to do, it's important because by default, Fusion doesn't know what the rules are for these parts. It doesn't know that it's a wheel and axle, doesn't know it's a lid and a box or the features. So when we create our joints and our constraints, these are parameters that we as the designers need to go ahead and set, which is hugely important as we go through and work with our assemblies. So let me just recap a couple important things that we talked about before we go into kind of our review and our Q&A. We have a lot of different flexibility with designing in Fusion, whether you want to bring a model in from Tinkercad or design something completely from scratch in Fusion. That obviously caters to what your students are doing, how they're already learning. If they're learning in Tinkercad, you want to bring them into Fusion. One great way is to actually just start in Tinkercad and literally import your models, like my toy car. But then show them how they can enhance their designs through adding different fillets and chamfers and features and things like that. And once we get into assembly, before we can assemble, we need to make sure that we have our components. And that is one step that I know a lot of folks miss in the beginning, is you can't just have bodies. We need to make sure that we have components that can be manipulated so we can set constraints and things like that. And once we have those components, then we can create joints, whether we want to move things in place or as-built joints. We can do that too, which is super great. And that allows us to create motion, simulation, and you can actually go back and, of course, review and preview your motion as you designed it, which is super cool. So you can actually see how things would sort of interact. And I want to kind of end with a couple things going ahead here. So I see some folks ask the question about what about separating and 3D printing these components? We talked about that in our first webinar, but that's a great question, right? If you create an assembly like this, and then I actually want to go ahead and 3D print, this car, I can't 3D print it in a full assembly like this. So what might I do? Personally, I would actually save this as a second design. So I would save this as a copy. And in my copy, I would actually delete my joints. So if I wanted to construct my joints, if I wanted to construct this and simulate, that's fine. If I actually wanted to 3D print this, I would want the components to be able to be moved and dragged. And I would actually click on my components and find the best angle and things to lay these flat for 3D printing or whatever it is that I might need to do. So you don't necessarily want to do this assembly and things if you plan on taking these models apart. Something else that you can do though, if you don't just want to delete them or make a copy, you can always suppress these features. So for example, if I right click on all these joints here and if I hit suppress, that should allow me to disable them without deleting them, which means that even though they're still here, they're no longer active. So I can click on my components and I can move my components around to arrange these for 3D printing or manufacturing as you go. So kind of two different features, right? If we want to make a model to see how it would interact, we want to do these assemblies, these constraints, these joints and things like that. If we want to actually then separate these and 3D print them in multiple parts, you wouldn't necessarily need those joints and those constraints as we go. But that said, one more thing that you can look forward to, which is what our next webinar is going to be, is what if we actually wanted to render and animate these? So for example, what if I want to make this box look like wood and make it look like a product sitting on a shelf in a store and actually have an animation where the lid slides on and slides off? Well, that is what the next webinar is going to be, because in addition to the design window, which is where we spent our whole time tonight, we also have the animate window and the render window where we can make models look extremely realistic. And that is something that we're going to be talking about in our next webinar in the new year. But before we say goodbye and before we sign off, let me switch back to my slideshow to talk about some really key important takeaways here. So first off, I saw a lot of great questions, and I know some of that I went kind of quickly and things like that. So I just want to remind you that this webinar is being recorded, and we're going to share that out with you tomorrow. And also that every single thing that I showed, even though I demoed it live, has a slide. So when we share these slides, you can kind of go back and see key features and things like that. So while I didn't show this on the screen, this is going to be shared out with all of our attendees to kind of review and talk about all of the things that we went over here in the webinar live. You can go back, you can refresh, you can see the key definitions and things in the slideshow that we share. And as I mentioned, if you are looking for more resources and things like that, there's tons of great things linked in this slideshow. Like for example, a web page about leveling up how to transition from Tinkercad to Fusion, as well as great guides and tutorial videos and things like that. They're all in here that you can utilize as we go. Something else that's super cool that I love to bring up for all of my secondary educators is that you can also obtain a Fusion 360 certification through Autodesk Certifications. And that's either you as a teacher, if you want to be certified to use Fusion 360 or become a certified Fusion 360 user, or also your students. If they're looking to apply to different colleges and things like that, they can get these certifications and then put that on their applications to say that they are certified for using this CAD program. And Autodesk has that for a number of CAD programs, not just Fusion 360. So I highly recommend you check that out because it is a really worthwhile thing to do to kind of gain credit for all these awesome skills that you are learning. And for you attending live, thank you so much for being here. We're also going to send a 1-hour professional development certification in our email. So tomorrow you'll receive an email with the slideshow, recording, and a PD certificate, just of course giving you credit for attending this webinar live. And before we dive into our Q&A, I want to invite Randy on over here to talk about some exciting contests and things in the Autodesk community.
Right. So one thing to mention, on instructables.com, which is a project sharing website, we have a teachers page, instructables.com/teachers. And as you notice in the it's this little slide on the left there. If you notice on the bottom right corner of that little slide on the left, there's a Autodesk Fusion 360 button. And if you click that, you'll find a whole host of hands-on Autodesk Fusion projects that you can use in your classroom. And they've been vetted and they're organized by grade and subject. So you should definitely check that out. And we also have contests, and we're running a number of contests open to students using Fusion. The first one I should mention, we currently have open. Actually, this one's not for students. This one's for educators, project-based learning contest. So if you have anything you use in the classroom and you are US-based and you want to share your project, there's a chance to win $40,000 in prizes. So I highly encourage you to check out that contest. And we have for students the CNC Design Challenge. So anything basically using CNC and Fusion is eligible. Any student using CNC and Fusion is eligible for this contest. So whatever they're making, have them document the process, share it on Instructables, and they could win prizes. It looks great on the college resume. And finally, the Anything Goes contest, which is literally open to any Instructable you post on any subject, on any topic. I highly encourage you, if you ever thought about sharing something, this is a great contest to kind of get started with.
Yeah, and that's super exciting. And before we go into our Q&A again, let's talk about some things up and coming. We have a number of weeks before we see you again, but same place, same time. We'll be back on January 18th for our next Level Up with Fusion in Secondary Education webinar. Again, the theme of that is going to be all about rendering and animation. So we're going to take some of these multi-part designs, make them look super realistic, or make animated videos of things kind of disassembling or rotating into place. It's a really great way to bring multimedia, TV production, and things like that, those types of conversations into CAD and in our modeling. Imagine that your students are designing something like a product that they're going to put on sale. Right in Fusion, you can design the parts, prepare it for manufacturing, but also make it look realistic for rendering and things like that too. So that's what we're talking about the next one. And I also saw some questions about CNC and even electronics. And again, we have a whole number of webinars planned, many of which are announced on the blog page, but even more coming throughout the 2024 year. So just stay tuned, keep an eye out on the Tinkercad blog and the social media, because we'll be promoting all of those things in the weeks to come. So we're going to dive into our Q&A, which means you're going to have a chance to see the Autodesk team in full screen. So hello. And before we do, I just want to again thank all of you for being here live before I know some of you might sign off. So thank you so much. Hopefully this was helpful and hopefully you enjoyed this. And again, please keep an eye out for an email from us that kind of recaps and reviews everything. So thank you so much for joining us, and we look forward to seeing you in the new year. So hopefully you all have a lovely holiday season and new year wherever you are.